Now, I don't know whether we're going to be able to do anything with this. I'd want to do something with this because it's the Rotel 220 that eagle-eyed viewers saw on my shelf when I showed a picture of my shelf, and I wanted to do a full recap because although it's really against my way of thinking, you only replace what's necessary, when we did the audio line Uniden sets, there was a significant improvement on most of them, and you have to change full capacitors in those anyway. Then we did the great GT868, and unbelievably that worked better, though I still haven't finished that because it's a squelch problem. Then we'll do an on-the-air test. So the only other set which is a major contender chassis-wise, I suppose we could do the Maxon chassis, but I've never known any capacitors to fail on those. Oh, I think I changed one in 38 years, and that's probably because it was overvolted. Anyway, this is a set which has been passed on to me as scrap, so we don't know. But I'd like to get it to work, take some figures off it, and then do a full recap. So let's hope that it's doable. That's the lid on the floor. Just seeing whether it smells of burnt out. It's, to be honest, it looks untouched. That. I think what we need to do is, I don't know whether you can see on this board, but there's an area here, area there, area there. That could be water ingress, like the chassis's been opened, it's been in a shed, water's dripped onto it from condensation. It could be spiders' webs. So we're going to just deal with that with isopropyl alcohol, because back in the days when I had a television shop and video recorders were coming in, this kind of thing on the back of a printed circuit board would have caused the Nichicon to be haywire. So we may as well use that experience and find the little brush, which I know we had. These are the RS special brushes. I think they're £5.95 each plus VAT. I mean, we usually use a cheap paintbrush from the pound shop where you get a pack of 3 for £1 and cut the bristles off. But these are the proper RS ones. So we'll use the right tool. This normally lives on Mr. Chippy's bench, but I pinched it. So that's today's precautionary and sensible thing to do. Now I do have a mic full Cybernet standard, which is here. Not sure whether we have a power lead. We do have a repair still in. I've been quite inundated with repairs at the moment, and some of these have been from end users. We've only got one on the shelf, and I really want to get this one out of the way, which is one of our sets, for this demonstration purpose. So that customer, I'm afraid, is going to have to wait a bit longer. We actually offer a trade-only service, which is 28 days. So, you know, if these things get done in 7, well, that's a bonus, isn't it? But I can only do 1 CB radio per day, because at the end of the day, this business is in church pipe organ restoration, and the electronic side of the business is very secondary. So, and we're currently installing a small pipe organ, which we've now been doing for a year because of lockdown. I've not been to the church very often to get on with it, but I think another 6 hours and that job will probably be finished. Of course, whether the bit we're installing actually works at the end of it, or whether it's been eaten away by mice while it's been sat in the church, will be another matter. Mice love church organs. There's a lot of leather, and we have to use animal glue, not modern glues, because with organs having a 300, 400, 500 year life expectancy, the plan is that they're there forever, and you don't want to be using modern adhesives which can't be got off. In 75 years' time, this organ will come up for overhaul, and they'll need to be able to steam glue off and redo it. So this is how it is. It's a shame we lost all our ancient organs in this country with the Reformation in 1662, was it? But that's how it was, and so most pipe organs in churches are really post 1860. So that's bored you to tears on church organs. Our building work commences here in June, and that building will contain a permanent pipe organ for me. Okay, so here we are with the Rotel 220. Switch on the power supply. Yesterday we were doing those walkie-talkies, which were 12.6 volts. So we'll jack the voltage up to 13.8 because this is a normal CB. So switch on. It actually lights up, and then we've got a channel display. It transmits. And at the moment it's doing 3.8 watts. If I switch picture in picture on, you'll actually see that. So there's 4 watts, there's 3.8. So let's look at deviation. Wallow. What deviation? 1, 2, 1, 2, 1, 2, wallow. 1, 2, 1, 2, wallow. I'll reach for the monitor receiver because I can't see any deviation. Testing 1, 2, 1, 2. There is no deviation. So what's happened here? Need to make sure the automatic level control's in that center position, which it is. 1, 2, 1, 2, 1, 2, 1, 2, wallow. 1, 2, 1, 2. So we've got nothing deviation wise, so this is when you start to think, well, has somebody put some daft Roger bleep on and then not kind of rewired it back, or whether the radio has actually got a fault. So just looking at the wiring, I can't see a problem there. So I'm just going to touch a screwdriver on the audio hot, whichever one that is. There's nothing there. Little bit coming out there. The audio, I think, is you've got a speech processor which is back there. There's quite a double op amp which is used as a speech processor, and then you've got some audio going to be pre-amplified into the audio IC as if it was AM, which of course it isn't. That's then fed back as through the AGC circuit, and then the whole lot's presented to the varicap diode, which is somewhere down here. And is it that one? Well, the way that yeah, it could be. I'll have to look at the circuit diagram anyway. So we need to get this working in order to do our modification, our recap. So let's see whether it works on receive. Of course, if it doesn't receive, it may be, if there's no audio, when there isn't right now, it may well be that the audio IC is up the swanny. Now, the Toshiba TA7205 down here, which is the audio IC, often when they are distressed, like they've been reverse polarityed or overvolted, you tend to find that there's a bulge where the kind of works has blown up inside. And I'm looking at it very carefully to see if there is a bulge. And you know what? Could be. These are getting quite pricey these days as well. So we have no received audio. So what I'm going to do is we'll put the signal generator on channel 20, so we're on 2779125, and we'll see whether the radio is receiving by turning up the signal generator. And look, we've got deflection on the meter. So turn the signal generator off, and the signal drops. Turn it on, and the signal's there. So it is receiving, but we can't hear it. So the chances are that the audio IC is not working. So I think my first port of call, just do one final test, and that is to see whether we've got audio on these wires. I'll just drag back the original speaker. First of all, we're going to check this for continuity, because you never know, we could have multiple faults when it's a scrap set. So as far as number of ohms goes, 7.2. We do have an impedance meter, and seeing as this is a kind of demonstration, why not get the impedance meter out and demonstrate impedance meter? So it was 7.2 ohms. (7.16) for impedance. So that's that. That wants clamping better, because that is so near the earth. You know, it's only 1/8 of an inch away. Anyway, that's something to deal with. I think the speaker's been changed probably. So we know the speaker works, so it doesn't matter which way we connect this up. I think no, I can't remember which way they are, and we'll check that before when we finish the set. But there is no audio. So put the speaker back down. The reason I did that test is in case we've got a problem with the speaker socket, and I'll just check that on the pins. There's nothing. So what I need to do is to change the audio IC. Right, so I've changed the audio IC. That's what's come out. There's no physical signs whatsoever of it being duff, but duff it is. We've now got received audio. That probably means we've now got transmitted audio. So we'll go back to deviation. 1 2 1 2. Yes, we have deviation. 1 2. Wallow. As it happens, I mean, I was messing with the deviation control. We're about where it should be anyway. So we'll come back to that in the tune-up. No, we won't. We'll do it now, and it won't need doing again. Turn the monitor receiver off. Wallow. Testing. No, it's still too low. Wallow. Spot on. 2.2. Okay, so there we are. I'm going for a coffee break, and we'll do a quick tune-up and see if we can get the best out of it, and then we'll do that recap. I was tempted to change that and that whilst the audio IC was out, but I didn't do so. Right, we'll start with the tune-up. We'll start with the VCO. Doesn't matter how many hundred of these I do, I still need to look at the service manual. So it's channel 40. Test point 1, 4 volts. Now these are a floating earth, so I'll just connect my negative prod to the power supply negative. Check by putting my positive on I've got rail voltage, which I have. The far side of resistor 4, and that's high. It's going to transmit. That's low. So just check what we're doing here. They have you start with receive. So the VCO coil needs to be 4. If you don't do this, you end up with channels dropping off at the extreme ends of the set. You know, you might find that channels of channel 37 don't work or something like that in different temperature conditions. A bit like a Midland 78 plus multi does when it's normally working. Says he with 2 of them. So now that's altered the transmit. So we'll just trim that. I mean, it's clearly been fiddled with this. It wouldn't do this on its own. That's near enough. Go back to receive. That's now slightly high. That's now receive 4.03, transmit 3.8. So I now will need to trim that. It's a bit of a backwards and forwards job. 3.91 for transmit, 4.045 for receive. What you now have to do is to go to channel 1 and check it somewhere around 1.8 to 2.5. So there we are on receive, and there we are on transmit. So that's beautiful, or bootiful, as a late chicken turkey bloke used to advertise. So let's hope that's Bernard Matthews, wasn't it? Right, so that's the VCO setup. We'll go through the transmit. So that's peak now. Wasn't. That was peak. That's also peak now, and it wasn't, so that's an improvement. Do you know what? I'm doing all this on channel 1. We'll just start again. No wonder it's made a difference. Peak. 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 So with the green plastic trimming tool, we now go over to, they've got numbers and I'll tell you the numbers. Yeah, it's 4, 8 and 9. 4, that's cracked and broken. 8, 9. See whether a different newer tool. So it might be cracked and broken, but it is actually peaking. Okay, so that's now peak, and as you can see, we've got 4.1 watts. So we have to balance this on these sets, and so what they have you do is they have you rotate L4, which is the first one, clockwise until you get 4.4 watts. Well, we don't get 4.4 watts ever. So it's now cooled down and I've got 4.4 watts, and I've just done that. Just started to move slightly down, so that's my peak point. And then L9, they want you to rotate counterclockwise to obtain 3.8 watts. Well, we're not going to do that. We haven't got to get it through customs, so we're going to rotate it counterclockwise to get exactly 4 watts, which is where we are now. Now I'm going to go to channel 1 and hope that's within half a watt. It's 5 point, yeah, it is, it's spot on 4. And on channel 40 it's about 3.99. That's about as balanced as I've ever seen. So that's good. I'm doing this meticulously because I'm not. What I'm not going to do is to pull the wool over people's eyes. I don't think this is going to make any difference by recapping this set, but I didn't think that on the other two I did, so we'll see. So that's transmit. With deviation we've already done. I'll set the S meter on transmit, so the transmit power meter, and it's clicked right over across the end stop, so we'll just adjust that for it to say 4 watts. Which is there. And then we'll go on to low power and see whether we're doing, well, we're actually doing 1.8 watts on low power. Just adjust that. .400 milliwatts. Back to the setting. Back to the setting. So that's transmit finished with. So on receive, we'll go over to the oscilloscope, which I'll actually switch on. Oh, we haven't done the frequency yet. I'm going ahead of myself. So 2779.125. It's so close that it's just there. There's not actually any point in adjusting that. It's so close. There you go. I've turned it to 1.8. It did drop down with age, so it's better to keep it very slightly above when they come in for service. So that's that. So back over to receive. We're looking at the oscilloscope. I want an S9 signal on the signal generator, which is 100 microvolts for a CB in the UK. And we need to peak the detector coil. Made a very slight difference there, which is good. I'll now turn the volume down so people who get annoyed, or they've got a dog that gets annoyed, can cope. While we've got S9 on the thing, we'll do the S meter. And as you can see, it reads S3, S4. So we'll pop that onto it now saying S9. There we go. Sensitivity. It's actually working very well. And right now, without touching it, Rotel RVC220. I'll just put this in RX 12 dB synad without servicing it. Wow. .34 microvolts. Well, I'll be surprised if we get that better. Right, here goes. Labour aside, so far this cost about £7.50 to fix. So we'll start with the front end. You know what? There's an improvement. Drop the attenuator. No further improvement. I think we're on IFs now, so we'll turn up the... You need to be able to see the difference. I'm not sure where the tools have gone off this bench. Okay, so let's now look at that. So RX 20 dB, 12 dB, 10 dB. Oh, what was it doing? I think it was about 3.9 watts, wasn't it, as it came out? We don't know what the deviation was because, if you remember, it wasn't working and I had to fiddle with it and change the IC. So let's look for this now. Let's see where we are with 20. So for 20 dB Cynad, we are looking at 1.59 microvolts. For 12 dB, now we're between scales here, so it says 0.2 on that scale, so let's try the other scale. It says 0.24, so we'll take the lesser. So look how we have improved it from as it came, and it was already very good. And then for 10 dB Cynad, .21 microvolts. Okay, I'm now going to spend the next 40 minutes changing all the capacitors for the Nichicon ones, if I can say it. I think they're all in stock. I know some are coming in July. You know, it's we're still in this lockdown situation, and stuff I've ordered in December is some of it's 6 months coming. But where we haven't got Nichicons come in stock, and I might have got them all for these, we will put other higher grade ones in. In fact, to be honest, we don't have any Billy No Mates ones. What I did do, just going off on a tangent, I bought a cheap Chinese kit of capacitors, but they're still 105 degree rated, and I think it's this one, might be another, and we're going to do a recap with cheap Chinese ones in a audio line at some point in the future and see whether that makes any difference, because it may be totally pointless spending good money on expensive Japanese ones when the cheap Chinese ones will do. Of course, you've got a lasting thing, haven't you, there, the longevity. There you are. I mean, they weren't the most expensive capacitors in the world they put in the first place, and the sets have lasted 38 years so far. So I'm just going to stop the video and now change the 22 capacitors, I think it is, in this radio. So we're nearly there, we've just got one to go. I've taken out the 1000 microfarad 16 volt one. It's got glue underneath. But I will just check this one. I mean, none of them may be faulty, but it's 38 years old, and this was what the idea was. So we'll just check this one. I will go through the others behind the scenes, because because I don't know whether it's glue that's underneath it or nastiness that's underneath it. Yeah, that's all right. It's slightly high, which is indicative that it's starting to fail. But the reason I said this is there is some glue underneath, and this, if it gets damp, it can become conductive. What I've just done is to get a screwdriver and just scrape away anything from where the pins are. I don't need to clear it up for it, so that it's all beautiful. But we will just change that now for a new one. And out of interest, we'll see how a new one compares. Yeah, so it's much nearer the mark. Good. And this will be filter capacitor, won't it, without looking at where it is on the circuit. All except that one, the polarity was quite clear on the board as to where they went, with the positive being marked. And that one I just had to look it up in the service manual. Had I not had the markings on the board, I'd have had to take serious notice as to where they came out from. This is the difficult thing. I'm on the three hand shuffle here, so that it doesn't fall out. So there we go, that's the final one, and we will hope, use the sharp cutters. I will be going over this with isopropyl alcohol. There's another bit of nastiness I missed there. So what we'll just do is we'll power it up and see whether it still works. So what I've just done, here's the problem. So I come to use the LCR and the battery's flat in it. So I went to where we keep the batteries. There aren't any spares. So this GP23A it takes. So I've borrowed this one off Mr. Chippy's bench. I've tried to read this on the other meter. And its reading is faulty, but of course it may be that this doesn't go to 0.33 of a microfarad without looking at the specification. This is why we're going over to another instrument. So I've disconnected one end. Make sure I get this one the right way round because it's polarity conscious. Yeah, that'll do. Oh, 33 microfarads. Oh, we can change that. I see. This is why I've tested it. I'd seen it as 0.33. Oh, right. We'll get that changed. Right. So that's done. So we live and learn. So it wasn't 0.33 at all. So I won't order those. So it either works or it blows up, one or the other. I've taken the knobs off and the lids are also destined for the dishwasher. This took a lot less time than doing a Uniden or the grate set. I don't know, it's just easy to find on the other side of the board. It lost a bit of weight because the capacitors I took out were mainly bigger. We're only talking about grams there. Right, well, we better start off on channel 40 and check the VCO. So that's going to need adjusting again. Oh, I'm not on channel 40. Still needs adjusting again. Let's go for transmit. No, it has you do receive first, but just for interest we'll look at transmit. 3.4. So the voltage has dropped. So we'll just bring that up. What I'm just showing you why I'm doing this is you can't just change the capacitors and not align it. So go for transmit now. Got 4.3. We'll just pop that to 4. .05, 3.96, that will do me. Let's go to channel 1. On channel 1 we've got 2.17 and the meter's timed out, and 2.28, so that's well within. So let's just go through transmit. So it's now doing 4.1. I don't think these are going to have changed at all. Oh, I need to change to channel 20. Four. Peak. 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 There's a capacitor under there which was hiding. Had to do that kind of second look around. Now I want the newer one of these tools, which is hiding under there. Peak. 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 So 4.5 is the absolute maximum. Now remember, we couldn't quite get 4.4 because that's the critical one. And again, I'm going to have to get this out. So we have actually gained some power on transmit. So 4.4 clockwise for, sorry, L4, clockwise, and L9 anti-clockwise for the legal limit of 4 watts. Now let's see how that's balanced. Channel 1, 4. Channel 40, 4. That's spot on. Let's go back to channel 20. I'll check the deviation. Wallow, 1, 2, that's actually dropped. Make sure that's in the centre. Just try it there. 1, 2. That's it. Back to how it was. RF meter. So key up. That's where it should be. Just it's very slightly on the spot on the 4 really. That'll do nicely. And let's see if low power is still 0.4 of a watt. No, it's not. It's 0.5. It's a bit dirty, that control, and that could be a reason. You know, I've changed more of these presets than any other repair on Cybernet ordered sets. So that's our transmit. So let's go back to the detector, 100 microvolts, and we'll switch to the oscilloscope. No alteration there. Tell you what we didn't do whether it was still on frequency. 2779125 is what we're looking for, and there it's still exactly as we set it. So let's look at receive. So let's try and peak it again. Start with the front end. Drop that to about 4 decibels. Funny if it was worse. I think the 20 dB will marginally be better. Yeah, I think we're there. So let's get the readings. Especially if any of you know what I did with my piece of paper. Oh, that's the one. Get rid of that. So we know it was, you know, it was capable of doing 4 watts when we retuned it last time. The deviation, remember we had to do the repair with the audio IC. So it's all received this. But we are now, remember we are getting more power because I had to turn it down from 4.5 watts, whereas last time we couldn't go beyond 4.2 watts. So, if we can find a pen, I'll do. Let's see what we've got now. So for 20 dB, we've now got exactly the same, 1.59. For 12 dB, we've now got 0.24. The 10 dB. 0.21. There is no change on receive sensitivity on this radio whatsoever. So the only thing that has changed, apart from buying it more time, it's 38 years old, and these aren't going to fail certainly in the next 38 years. We have increased the transmitted power, and I can put that down to better power supply stabilization. And in the early part of the circuit around the synthesizer, I just think it's got a bit more oomph for the transmit. So it's neither here nor there, but at least we were able to give it the legal limit easily, instead of it being like these modern sets where, you know, we have them absolutely thrashed and they're doing 3.6 watts. There was a change on the deviation. Something had changed in the audio circuit, hopefully for the better. But there's no difference whatsoever in receive on this particular set. So whether it's worth 40 minutes and 10 quid with the capacitors, I don't know. Right, let's set the squelch up, and then Bob's our uncle, as they say. So I'm going to turn the squelch to full, because we didn't bother with this before, and I want it to come into 100 microvolts. I've now got 100 microvolts on the thing, on the attenuator. And what we got, I will look at it on the spectrum analyzer for a laugh. There's a preset, couldn't find it, it was hiding. That's slightly dirty, I'll just give it a quick service hole. I don't know why people in the UK are using Deoxit, which is American, when the UK service hole Super 10 is a very well proven product right back to the 1950s. But there you are, that's my there we go. That's now spot on. And let's see now what the sensitivity is like. So switch the signal generator off. I've parked it at 0.3 of a microvolt. Set the squelch to threshold. Switch the signal generator on. So let's see where it's coming in and out. So squelch. So for threshold, we've got 0. Not much hysteresis. Max sensitivity 0.9 microvolts. I'm going to just reset that. We'll just reset it again in case I didn't do it well enough. Oh, that's better. .65. Open. .58 closed. So that's the maximum squelch sensitivity I can get. That's fine. So we'll do it on the spectrum analyzer later on today. I'm going to have to take a break and do something else. And then we'll do an on-the-air test with Mr. Chippy later on. Hopefully by the time I come back we'll have got the things through the dishwasher. I can't take the front off because you've got to unsolder the mic socket and it just isn't worth the bother. I'll give that a quick wipe over. So we'll look at the transmitter now on the spectrum analyzer. That's our fundamental. Let's have a look at our dodgy ones. So we'll measure that. So without any adjustment, it's round about 55 dBm, which is just about within what you'd expect. So I don't need to touch it, but it hasn't really been messed with anyway. So that's just verified that at least it isn't doing anything ridiculous. I wonder what it's doing on 110 megs. Oh, not pressed the wrong button, haven't I? Yeah. Somebody, I got one of those sets in some time ago, one of those with the Amstrad type chassis, which is a Cybernet 002F, and Wally linked the resistor out, and on a cheap meter, it it shows like you're doing more power. But our experience is you end up actually doing less on 27 megs, and the average has been about 2.8 watts. But they show 10 on a cheap meter. Just talking of cheap meters, let's see what this is doing. Yeah, it's doing 5 on the Zetagi meter, but we know it's doing 4. So part of that is harmonics, and the other part of that is these are manufactured to show rather fast. So I looked at the spectrum analyzer on this Amstrad. So we're doing 2.8 watts on 27 megs, doing 4 watts on 55 megs, and we're doing about 2.5, 3 watts on 110 megs, right in the middle of the aircraft band. So they actually decreased it and built up the harmonics, you know. Wow, clap, clap, clap. Isn't that clever? Right, back to this. We're done. Okay, so we put it back together. We actually put some screws in the side. It's been through the dishwasher. It's probably one of those sets that could do with a respray, but it's our set at the end of the day. Now, just mentioning about these holes. They've actually drilled them from the inside, and so as the drill comes through, you've got on the outside you've got the kind of bulge of what happens when you drill. You must always drill from the face side, not from the inside. So it's just a point. You know, that can have body fill if you're going to respray it, but it doesn't matter. It's whether the set works. We've got a fluorescent light on in another room, and it's a really expensive one with a Swiss electronics inside, and I'm just going to turn it off because it's giving us S5 of rubbish. So I'll just go and do that. I'm just defrosting a freezer in there. Okay, let's see what we've got now without that light being on. So we've got S1 now of noise. 1 down, Roger. As ever, they're carrying out conversations 35 miles away. I don't know whether people are aware. What you're supposed to do is you go on the calling channel, which seems to be 19, and you say 19 for Fred Bloggs, and if Fred Bloggs receiving, he says, "Oh, hello there." You go, "Yeah, knock it up one, or knock it up a couple of channels." Not just sit there talking on it all day. It's very frustrating when you're mobile and that's going on every town you go past. Right, well, we'll do an on-the-air test later on, and that works very well. So in conclusion, the radio was doing 3.9 watts as it came. So, being balanced up, and it's doing 4. But it does 4 easily. That's the difference. If you remember when we tuned it up, we could get about 4.1, 4.2 out of it. And really the manufacturers want you to get 4.4 out of it so you can balance the transmitter between the channel 1 and 40 with their method. And we were able to do that easily when it was done. It then produced 4.5 watts, and we were able to follow those procedures, and the balance is absolutely spot on. It's 4 watts across all 40 channels. So we meticulously tuned it as it came. As it came, it was doing 0.34 of a microvolt, which is excellent. And then after meticulous tuning, 0.24. And after changing the capacitors, made absolutely no difference whatsoever. But it had increased that transmit power, even if it's only by 0.4 of a watt or whatever that is. So it just proves that the way the power is stabilized in a set, because you can have an 8-volt rail, and the way the synthesizer's generating its frequencies, its VFO, it is producing more oomph on transmit, which is good. We had a major change to the deviation level. It was actually lower after the capacitors were changed, and well, you know, we'll see what it sounds like on our base station tonight, but these normally sound very good anyway. So there was a change there, and I would, if we were testing audio outputs on receive, you know, as in how many watts the radio is doing on receive, then I'm sure that it's actually doing it better than it was before. I did expect the 20 dB to improve, and it didn't. Just wondering how many watts it is supposed to be, according to the manufacturer. It's 1.5 watts into the 8 ohm load. So there we have it. So I hope that was interesting, and we've finally done the Rotel 220, which I've been hankering over doing for weeks. Thank you for watching.